Stephen Wisdom is a well-known expert prop maker and historian who has recently made a full-size replica of the British Interplanetary Society's Lunar Suit as designed by Harry Ross and Ralph Smith in the immediate post-World War II period. It is now on permanent display at the National Space Centre in Leicester. Stephen's personal story, though, is much more rooted to the past than just a passing interest, as he has lived and breathed history in many forms for over 30 years. He is fascinated by the how of history, by the nuts and bolts, the engineering and the mechanics by which the adventurers and explorers of the past made their great journeys. He has built replica 1930s racing cars, full-size World War I aircraft, and is a near permanent feature behind the lens when working with numerous television and film projects. The conquest of space has been a particular love, and he is working on 2 highly accurate Mercury-era suits and has plans for a Mars suit to go with them.
Hello there, ladies and gentlemen. My name is Stephen Wisdom. I'm a model maker, a costume maker, and a historian. Now, when I say costume maker, I don't mean a period costume maker sewing lace on bits of wool. In the case of what I'm going to be talking about here, it's about how myself and the folks at the National Space Centre in Leicester in the UK developed and designed the replica of the British Interplanetary Society spacesuit from the late 1940s that's now on display in the galleries in a permanent exhibition. Now, as I tell you how we made these design decisions, you might think that initially I'm talking about other aspects of the design and not really about space and spacesuits, but bear with me, it will all become clear. So, ladies and gents, reimagining the BIS Moon Suit for construction. A little bit of history of how we got to this stage. Years and years ago, as a historical performer, I'd come across this story and thought it was very interesting and wanted to develop a live show about it. So when the curator at the National Space Centre, Dan Kendall, came to me and said, "Are you interested in building a replica of the BIS Moon Suit?" I said, "I know all about that. I used to do a show about it." Now, it has to be said, when I dealt with the show originally, it was all slightly focusing on the more comic elements of taking sandwiches along to the surface of the moon. But this time it was very clear that myself and the museum wanted to seriously look at Smith and Ross's designs from the 1940s and come up with something which was pretty much as they would have thought about it. Now, I was up against a few other people who were going to be pitching for the costume making as well. And it was very clear also that they were costume makers rather than historians. So I took a completely different approach in my presentation when I pitched for the making. And I said, look, it isn't going to be cheap because I'm going to make design decisions all the way through the making process, and those design decisions are going to be guided by the materials that Smith and Ross would have had available. So, for example, if you were making something out of a silvered material today, it'd be very easy to go down to Petticoat Lane in London and buy some spandex or something like that, a mylar covered nylon. So very quickly we looked up to see when mylar was invented. Wasn't invented when Smith and Ross were coming out with their designs. So it was clear that other approaches would have to be taken. And that became the driving force of this whole design. So reimagining the BIS spacesuit, where do you start? Well, we start, of course, with the original design. So here we have one of Smith and Ross's original designs here by R.A. Smith. And we'll look at that in a little bit more closer detail in a moment. We've got one of those very, very classic illustrations done by the guys at the time. It's our astronaut. He's sitting at his console. He's got his helmet on. He's got his rubberized suit with what they call convolutes. Bit more of that a bit later on at the arm to give a bit of mobility. And if we look at the close-up a little bit in a bit more detail, we can see that what Smith had done, and that's 1945, remember, so the war has just ended. What Smith had done is he'd annotated this design with all of these numbers around the edge, and that would give myself and Dan, the curator, a huge clue to the way the BIS were thinking way back when. So let's just analyse what we're looking at there. We're looking at effectively a rubber bag that's covered with thermal layers, which Smith envisaged were going to be wool. They were going to be, in some cases, leather. They've got boots with asbestos soles. And if you look right down there at the bottom of the drawing, number 16, they've got spikes on the soles of the boots. And that was to reduce contact with the lunar surface because, of course, they knew the lunar surface was going to be hot. So to prevent thermal transfer, they were going to make those little spikes at the bottom. We've got a backpack, much like the Apollo PLSS. We've got a helmet, and that means we're going to have some kind of airtight seal for the helmet to lock on to the suit. Now, 21, if you look at the drawing there, you'll notice there is some kind of cape hanging down. All of this had to be taken into account, and luckily Smith and Ross had left us with some idea of what that cape was for. It was what they called a sun cape. When you wanted to reduce your temperature on the moon, when solar radiation was touching you, you would pull the coat around you, or the cape around you, and that would reflect some of the heat away. When you wanted to get warmer, say you're in a shadow, you would reduce that, and the black, or reduce the amount of volume of the cape, you would pull it back, and the black body of the suit would absorb heat from the sun. So they clearly had a good idea of the physics of how it might work on the moon, but that didn't help me. All I knew was that would be my final finish. I needed to construct something which was pretty much like that. So we had just 2 or 3 drawings to go from, and this was an absolute delight when this drawing turned up, which I think is in the BIS headquarters. Lovely charcoal drawing, but it gave us more of an idea of what those knees and elbows and shoulders were looking like. And again, we were coming back to that idea of rubber joints at the hinge points. Particularly, this drawing helped us out a little bit later on, because if you look on the back of his backpack, you can see a geological hammer. Now, actually, when I saw this, it was really late on into the design process, and I actually phoned the curator and said, he's got a hammer on his backpack. He's got a geological hammer. And as we would find, there isn't a hope in hell that you're going to be able to reach that yourself. So a little bit like Apollo 14, they have tools on their life support that I think they probably couldn't have reached themselves. So we've got these lovely drawings, and we're all familiar with what a spacesuit looks like. It was clear from these drawings that we were going to be well away from the classic Apollo look. Now, if we just look at this Apollo suit from 1969 onwards, you can again see those rubber joints there at the arm, those convolutes, those concertina joints. And this would become very prevalent in the design as we went on. So where do I start? Well, luckily, I'm a period diver, and here I am putting on my diving suit and preparing to dive with 1940 dated diving equipment. So let's just stop for 2 seconds, and I'll just do a little proviso. The next part of this talk is going to sound like a history of diving, but you have to remember that Smith and Ross, that's all they really would be familiar with. Aviation oxygen development, high pressure equipment that was being developed by both the Germans, the Americans and the British in the Second World War, which of course had only just finished, and diving equipment, which was pretty much reaching the zenith of its design. So what I'm wearing here is an Admiralty pattern suit. This is a replica suit because I don't want to die if an old one breaks underwater, but everything else is original. As I say, that gorget, this piece here, is about 1940 dated, and I'm just about to put on a helmet that is 1914 dated. Everything works. And of course, diving suit designs is what Smith and Ross would have been familiar with. So I think, and Dan, the curator, thought as well, they would probably have gone down to Sieber Gorman's in Chessington in Surrey to say, we want to make an airproof suit for use on the moon. Now, this is me underwater, and you can see here the beginnings of one of the problems that will be hounding designers of spacesuits right through to the Apollo era and beyond, and that is ballooning at the shoulders. Let's take a bit of a closer look at just that problem. So here's some footage of one of my colleagues, it's not myself, going underwater. And this is brilliant stuff. I don't know if any of you are astronauts and you've used any of the underwater tanks. I'm not a scuba diver, so for the first time when I went underwater, this was pretty marvelous stuff for me. So essentially, a spacesuit is an airproof or a vacuum-proof bag, and our diver here, he's got his shoulders, as we will freeze frame here, he's got his shoulders and they're beginning to balloon. So the pressure inside the suit is now beginning to balloon around his shoulders, and that will reduce mobility. Underwater, he's reasonably mobile because he's reasonably buoyant, but where those shoulders are beginning to balloon out, if he was in space, he would now be, or in a vacuum, I should say, he would now be very, very inflated. And of course, this is a problem that spacesuits had all along. So Dan, the curator, and myself began to see that, well, we needed to do something which would restrain that suit and keep it in. A rubber bag, an airproof bag, would be absolutely fine. So I started to look at designs of diving suits, and here we see the Sieber Gorman factory in 1908, and all of those pieces are being glued. So that was the second design decision we made. We would make a rubberized bag for the interior of the suit, but we would cover it with cloth and glue the seams. So actually here I've got a real piece of diving suit from about 1914. And this gives you a good idea of how these suits were constructed. Now, this would have been made by those girls in the Sieber Gorman factory. And let's just have a look at the construction. And this is what we were trying to emulate with the suit that I was going to make. So we've got a rubberized inside there, and that faces another rubberized inside, and the outside is covered with cotton drill material. So everything is glued together and then laminated, but the critical thing is, and you can see the join there, again, it's glued. So these rubber cuffs, this suit here that's glued and covered with canvas, it gives you a very tough, very restrained, because that's what the cloth is doing on the rubber, it gives you an airproof restrain layer. And again, I'm sure those of you who are involved with science and space suit development, you'll know that that is a very important thing in any pressurized garment. So space suits and diving suits, we began to feel were the way forward. So we've seen that diving suit design was the way forward. And again, here's another picture of the Heinke factory. And right in the extreme background, you can see a diving suit that they have been constructing there with the helmet on. So Dan and I, the curator at the museum, and I decided that we would definitely go with a rubber core, a rubber bag, effectively. We would go with a cotton drill outside, and we would go with glued seams. So the next design development was really to think about mobility, because as we know from talking about previous missions, if you've got like Alexei Leonov when he inflated on the first ever spacewalk, if you've got a suit that just inflates up like a bag, even with a restraint layer on it, you'll need some form of mobility at the arms. So mobility when suit inflated was clear it would be a huge issue. Now, there'll be some of you saying, this is going to live in a case. Why is he making all of these decisions as though it's really going to go to space? Because we wanted, by this point, to make something which was as good an attempt to replicate what Smith and Ross were thinking as we could, within budget, obviously. And there'll be a little bit later on about how something was so complicated, we just had to take a shorter cut. So yeah, mobility when suit inflated would be a huge issue. So we've got to think about some form of basic concept. And here we are with our friend. And it always turns up when I talk about the development of the spacesuit, bit of Latin coming up. This is Manduca quinquimaculata, the tomato hornworm. Now, the reason why we've got him in our talk about spacesuit development is because in 1943, a designer from BF Goodrich, a guy called Russell S. Colley, was watching a tomato worm on his tomato plants, and he saw it turn by 90 degrees. And as it turned, he noticed that its body segmented concertinaed and convoluted by evolution. He noticed that as it turned, its body didn't compress. It just turned like a concertina pipe, but at no point changed its completely round shape. So he thought, if we can replicate that in rubber, then we can turn a 90-degree corner, say on an elbow or on a knee joint, and we will still retain pressure within the suit, providing we put enough restraint layers of cloth on it. But we will not crush the inside of the elbow or the inside of the knee or the inside of the armpit and the shoulder. So the suit that BF Goodrich and Colley came up with is nicknamed the tomato worm suit. And here we are in 1943. This is an American design for a high pressure, a high altitude suit. I think it's an absolutely brilliant design. And you can see at the knees, you can see at the elbows, and you can see at the not so much at the shoulders actually, but you can see at the bend points there, you can see these restraint concertina rubber joints. Now, the trouble with this suit was that when they inflated it with air, it just seized up. And even when they inflated it with oxygen, it still became very, very stiff. Now, again, I'm not a scientist, so some of you may be able to pick me up on this. But the way I understand it, to give the human body enough air to breathe, we need to put air into a suit at about 14.7 pounds per square inch. To give the human body enough oxygen, we can give that same suit only about 3.5 to 4 pounds per square inch of oxygen, and that will provide the astronaut, the wearer, with enough oxygen to maintain life. But they do need to pre-breathe that oxygen, which is, I believe, why astronauts you see today are pre-breathing oxygen before they get into their capsules, and they're walking out fully enclosed, pre-breathing oxygen, or I believe it's oxygen and nitrogen now, to provide a less of a fire risk. Now, if we look at the picture on the right hand of the screen, the one where the wearer is looking at you face on, you can see a zip running all the way down the front of the suit. So there's a locking helmet where that dome will go on, and that zip all the way down the front of the suit will mean he can ingress the suit. So I began to think, well, let's put a zip on the suit somewhere. But then we went back to Smith's and Ross's design, and it was very clear there was no zip. So now we've got to think about how the wearer is going to get in. And the answer, once again, comes back to diving suits. Now, when I wear my diving suit, I have a very wide rubberized cloth neck, which I wriggle in through, and then that all gets folded up, and then the gorget, that large copper plate, goes on, is bolted down, and that provides an airtight and watertight seal. That won't work on this suit because it's very clear on the original design that there is some form of neck ring, ovaloid, not round like an Apollo one, and that neck ring very clearly was going to be the way that the astronaut was going to have to get into the suit. There's no other way that Smith and Ross had indicated you could get into the suit. And of course, now we've got to start modelling this in 3 dimensions. I'd drawn it out, and I started to make notes of where I thought the width of the neck ring would have to be big enough to get someone of my size. I'm 6'1" and reasonably slim to get into there. But a 3-dimensional model has to be the answer. And as you see here, very early on in the design process, we put big rubber shoulders around, big, deep rubber shoulders. Now, as will be revealed as we talk about this suit later on, they wanted to have big, deep rubber shoulders so the astronaut could withdraw his arms inside the big, pigeon chest so he could get to the airlock, and a little bit more of that a bit later on. So as you see here on this maquette, this model that I made in plasticine, there's a big, deep armhole. Is it on Smith's original design? No. So very quickly, we said, lose the big rubber convolute. So that's gone. Instead, we just relied on lots of extra movement, a bit like my diving suit. So we drew it out. We drew it out with the big, deep armhole, so the arm could be withdrawn inside that big chest you see here. And then I started to make the rubber convolutes. Now, normally, they would be a whole rubber tube, effectively, that would be joined onto the rest of the rubber suit. But the budget didn't extend to casting an entire rubber convolute section. So instead, we made half sections. And this is where I've used a modern material, because at the National Space Centre, the atmosphere in the rocket tower where this is displayed, it can get very humid. What I didn't want to do was use latex rubber, which is what Smith and Ross would have used, because latex rubber is notoriously unstable in high ultraviolet conditions, and the rocket tower is made of transparent material. So I didn't want this breaking down. As a result, this is black silicon. It's pretty much like I think they would have come up with in its shape. As I say, it's not the right material. So now we've got to think about how we're going to get into the suit. So getting into the suit, ingress, was obviously going to be something that we had to think about, and that Smith and Ross would have considered as well. Now, one of the things that we think they would have been looking at is a thing called a Sladen suit. So this is a Sladen suit from about 1943. It's a diver's suit, yet again, for Royal Navy divers using those, what they call the chariots, these human torpedoes that were steered onto a target. The reason I'm showing it to you is that it has a very interesting neck or front entry, much like a modern-day Russian Sokhol spacesuit does. Let's have a closer look at how the divers would have worn this suit, and it would have been very familiar to Smith and Ross. They would climb in through a thing called the umbilicus, which would be a large tubular front, and that's what you can see around the man's waist in picture number 1. Now, picture number 2 looks like it's on, but if you look down his back, that's actually the neck ring. What he would do is pull that up his back, over his neck, and now in picture 3, you can see the umbilicus hanging forward. That gets folded in, again, like a Russian Sokhol spacesuit, and then sealed in watertight by a series of straps. The final pictures of the suit all strapped up, and that's how these divers would have gone into action. And again, a rubberized bag, but it would have inflated, no restraint layers. But it was interesting in that we could see that front entry. Well, I decided that the best way to get into the BIS suit would be through an enlarged neck ring. So I made a cardboard former and climbed in and out of it to make sure I could fit. If I, all 6'1" of me and a 42 chest, could get in, I'm sure a slightly skinny astronaut corps member of the Royal Air Force or something like that in the 1940s would have done. So there you see a gaffer tape mock-up, what I call a buck, of the suit in my workshop, with it ready to start pattern cutting and working out how we were going to make it. And of course, then there's the helmet, that characteristic helmet that bolts down to the neck ring. So I've modelled the helmet here in card, in gaffer tape, and you see my design drawing behind me. Now, again, another thought that myself and Dan, the curator at the National Space Centre, had was that the helmet and the body would have to be made of fiberglass. Now, before anybody says, hang on, they didn't have fiberglass in the 1940s, I'd looked up the history of this. Now, actually, Smith and Ross had said, we're going to make the helmet out of fiberglass. So obviously, in the 1940s, they knew what glass reinforced plastic was. I think in 1939, the first plastic car body was produced. And in 1938, the Russians made an entire boat out of fiberglass. So it was a material that people were familiar with. And here you see the basic helmet shape and a very, very rough cast I'd made over that gaffer tape body to give me some form of hard upper torso that would live within the suit and be bonded in within those rubber sections. This didn't need to move, and the more rigidity that suit had to attach the airlocks and the convolutes at the arms, all the better. So we've moved forward a little bit, and here I am looking rather serious, wearing the suit. I've wriggled into it through that neck ring. To get in, you had to sort of wriggle in sideways because, of course, you won't fit normally facing forwards because it was quite narrow. So I wriggled in sideways, got my feet into the feet holes. So the whole thing is self-contained. It's completely sealed, and my arms through these very, very deep armholes. The covering here is cotton drill, just as the old diving suit section was, of course. So we've climbed into it, and you can see just at the front of my chest there, the airlock. More of that a little bit later on. Now, the helmet design was going to be something of an issue, as I said earlier. It had to be fiberglass, but Smith had declared that the helmet design was going to have to bolt down and was going to be silvered to prevent to reflect radiation. So to silver it, I looked up the process of vacuum metallizing. The helmet was being made of plastic, so it would be very difficult to plate unless you coated it with copper. So we're going to use a technique that was familiar in the 1940s for making telescope mirrors. And it was becoming more popular in the late 40s and early 50s for giftware and indeed for scientific equipment as well. So here at the helmet, much cleaned up from the earlier fiberglass version you saw. It's been rubbed down, it's been painted many, many times and rubbed down to get the smoothest surface we could. And now it's going to be sent to a company in Chertsey in Surrey, who have been around since about 1941, and it's going to be vacuum plated. Now, when I took the helmet to them, they looked at it and went, "Oh, space helmet." I said, "Yeah, this is an original design from 1948. And they said, "Yeah, they probably would have brought it to us originally. So it's nice to finally get it." Now, under that helmet, of course, would have to be a communications cap carrier. And again, specified by Smith and Ross that would be knitted. And so again, not knowing too much about it, I designed something, sent it away to a period knitter of 1940s knitwear, and she converted a Home Guard balaclava pattern and followed my instructions. And we married this to a throat mic and a set of period headphones, and you'll see this later on. There is the helmet when it's come back from the vacuum platers. Now, this is a very thin coating of vacuum plating, so the whole thing has been lacquered, but it does give you an idea of what that helmet would have looked like when it was finally done. So we've got the helmet, we've got the beginnings of the suit, we've got the tip-down tinted visor that you can see on this drawing here, but how did we envisage actually getting some samples? Well, Smith, as I said earlier, and Ross had designed an airlock in the chest. If we went right back to the beginning and that cutaway, we would have seen that wonderful image where there was an apparatus in the large chest of the figure in the cutaway. Remember I said the armholes were very deep. That is so that the astronaut could withdraw their arms inside the suit and look at a sample. How would the sample have got in there? Through the airlock. So envisage a situation on the moon. Our astronaut is walking around on the lunar surface. He sees a sample he's interested in. He picks it up. He opens the airlock on the front of that large extended chest. He puts it into the airlock. He closes the airlock. He locks the airlock. He withdraws his arms inside the suit. He then opens the inner airlock, takes out the sample, and down the long front of the helmet, through that large oval neck ring, he turns on a light inside the oxygen-rich environment. That's a filament bulb, which is scary in itself. And then he examines the lunar sample. Why not just give him a bag and let him just pop it in the bag? It's never really been answered, that question, but it's a kind of mobile laboratory on the moon. So he's got to withdraw his arms inside the suit. So now you can see the airlock in this drawing here, or this photograph here, and you can see these little things that we called the mushrooms, these little aluminium studs. Now these are for keeping that sun cape away from the suit itself. When the sun cape is pulled around him, you don't want it transferring heat from the surface of the sun cape into the suit, so you create a vacuum barrier, and that's what these little studs are for. They keep the sun cape hanging away from the body of the suit, and it's all to do with thermal transfer. So you're getting a pretty good idea now of what the suit is going to look like. Remember our diving suit sample that we showed you at the beginning? You can see that all the strips are glued on, and it causes some difficulties. Now, I apologise for the short film that's just about to start. This is me in the suit, absolutely stuck. And this is very popular, this film. It gives you a good idea of just how difficult getting in and out of that suit would have been.
Well, if I look like I'm going to be sick, it's because I'm probably just about to be sick. I've been stuck in the suit for, well, a good while, actually. My arm here is still stuck in the suit, but I've just used every ounce of my energy to get the hand I'm holding the phone with out of the armhole on the left-hand side. Now I want to bring my dinner up. I'm overheated. Exhausted. One of the problems they would have had is that these hands here, which are now glued on, just can't be withdrawn. Your hand's sweated up inside it. And they talked about putting a hook on it so you could withdraw your arm. But that's fine if you're using a massive great glove. They were using what they described as surgeon's thin rubber gloves. There's no way, not a hope in hell, that you'd be able to get a thin glove made of latex rubber off your hand where your hand sweated into it. So it's very clear that to egress the suit, to get out of the suit, you'd need a bit of help. I was on the verge of stumbling down the road and asking my neighbour to help. No, that would have been a bit weird. Anyway, I'm going to try to get out and we'll see how we get on. But yeah, limit the... Oh, excuse me, I'm going to be sick. Limit the number of times I put it on, most definitely.
So, yes, ladies and gents, that was me stuck in the suit. I did manage to get out, obviously. But what that showed was that we had to, or they would have had to put hooks on the cuff and on the hips, so you could actually hook your arm onto the side of the suit and then withdraw your arm through that large elbow hole, or the sort of large armpit hole, back inside the suit again. And that's what, if you go to Leicester and you look at the suit, you will see those hooks and those clips on the side of the suit for that very, very purpose. But now the suit had been constructed, the surface was on, the seams had all been glued. What colour is it going to be? Now, Smith and Ross said it was going to be a suit of a high silver finish. And again, as we said at the beginning, that suggests mylar or spandex or any of those modern materials, not invented in the period that Smith and Ross are talking about. So again, we turn to what was around at the time. And of course, what was around at the time was the wonderful silver finish you got on pre-war aircraft. I spoke to a company that restored this very Hawker aircraft you see in front of us and asked how it was done. I went to visit them and they showed me silver dope that you cover onto cloth, and they said this is about the closest thing we think they could get to at that period to be a high silvered finish. Now I said, why don't I vacuum metallize, like I did the helmet, the cloth? And they said, it'll just come out like this. You might as well use a high finish silver paint. So that's what we did. We used a high finish silver paint. Sorry about the slightly fuzzy photograph here. And you can see now that the suit being painted with this is becoming a little bit more like we would expect it to look, and like it will finally look like. Now, one of the things that I did notice was when I was looking at some Mercury suits. I've got a particular interest in the American Mercury project. Nowadays, they're going slightly brown. The silver finish on the rubber is going slightly browning, and I quite like that pointless detail. So here you can see on the right hand photograph, you can see that slight browning, as though it adds a little bit of detail. And you can also see the ingress instructions that we had printed up, and I got a printer who made period labels for period garments and things to make these all up for me. So we're getting there. We're getting to a point at which the suit is now looking much more like we think it would have done. But what about the famous backpack, the one that we see, of course, in the illustration that Smith and Ross had done all those years ago? Well, I had to make a backpack, so here you see the finished backpack. Sadly, you don't actually see any of this detail on its in the display case in Leicester, but you can see that geological hammer on back of that aluminium cooler that was welded up by a member of the Williams F1 team for me in his spare time. You can see those lovely hoses. They came from China because the Chinese still make hoses out of rubber and cover them with cloth, much as they would have been in the 1940s. And you can see all of those lovely period labels. Here you can see one of the period labels for the draining instructions for the suit. This is all entirely made up. It's just detail which I like to think would have been there. But these draining instructions are actually from a drain instruction from an Avro Lancaster bomber. And where it says set rad shutter to automatic in extreme sunlight, that's a bit of a nod to the 1954 film The Dam Busters, where the first line that Richard Todd playing Guy Gibson has is rad shutters automatic. So I just put that on because I quite like the idea of it. On the right hand photograph, you can again see those aluminium mushrooms, those studs for keeping the sun cape off. And you can see that I'm beginning now to make the attachment for the backpack. And I was going to use some really nice clips I got from an army surplus shop, which are like parachute attachment clips. Now we enter the thorny issue of the boots. Now, on that charcoal drawing you saw right at the beginning, those boots, of course, were they were almost like a rubber casting. I think they would have looked a little bit like this. This is a US Air Force or a US America Army Air Force boot from about 1943, used all the way through the Cold War as well. If you look at the sole, it's a rubber molded sole. It's beautifully made. And if you can make a pressurized version of this, an overshoe like this, I think it would have been pretty close to what Smith and Ross were thinking about. Now, I can't make this. I couldn't cast that sole easily, and I couldn't do that leather sewing. So I said to the museum, look, I just don't think I can go down that route. How do you want me to progress? And they said, well, go back to diving style again. You're good at that. You know what you're doing. So what we came out with was a boot design a little bit more like a diver's shoe. This is the one thing I don't think we got quite right. And on the left-hand photograph, again, forgive me, a little bit fuzzy, you can just see those studs which are poking down there, and they are showing the metal spikes which would have created that thermal barrier between the lunar regolith and the sole of the boot, which would have been made out of asbestos. Now, all good missions need a mission patch, of course, but of course, the BIS didn't have a mission patch. They didn't have a logo, but they did. Way back in the 30s, in about 1938, 39, I found this at the top of a very, very small pamphlet that the BIS had, a tiny little hand-drawn logo. So I said, that's going to be the mission patch. That's going to be the mission patch for the suit here. Now, it was very small, about 20 millimeters across, so I've blown it up here, and I did a design which I didn't like. I just didn't think it looked very period. I wanted something that looked a little bit more like the mission patches you would have found on flying jackets of the Americans and things like units like that during the Second War. Again, very familiar to Smith and Ross. So the same man who did those fantastic labels for me and the panels for the backpack, he came out with these wonderful embroidered patches, which are just stunning. When they arrived, I didn't really like them. They were a bit too pale blue, but I think he actually chose the colour really, really well. And they look really, really nice. So we put one of those on the shoulder of the suit. and there's one of them on the sample of the suit, sectional sample that we've got at the museum as a swatch to show all of the different layers as well. So what did it all look like when it was finished? Well, we've gone through the original process that Smith and Ross would have done. We've looked at diving suit technology. We've looked at boot technology. We've looked at the history of aviation pressurized garment development. But when it was actually in the case, what would it look like? Well, it looked like this. We've got here the whole thing put up in the case. You can see that helmet. You can see the aerial out the back. You can see those clips I was talking about there, just under the sun cape. You can see the weathering where I've just put that little staining on. But critically, there is one thing here that Smith and Ross didn't envisage, and it's the only thing that you really would have put in because otherwise the suit didn't work, and that is a strap around the crotch. Now, going back to my diving suit understanding, when you put a diving suit on, it is much longer in the body than you are. And the reason is that you need to be able to get your shoulders in. You need to wriggle into the diving suit, and then they pull the neck up around you. And you realise that now the crotch has sort of come up around you. And when they lower that down, the crotch hangs very, very low. They put a belt around your middle on a diving suit, and then they strap you in really, really tight around the crotch. And the body needs to be longer so you can simply get into the suit. You need to take in all your shoulders and get into the suit. So that crotch strap you see here is the one addition we had to put in to get the suit to actually sit right and not hang really, really low in the crotch. Everything else is as Smith and Ross pretty much envisaged it. The black chest to absorb solar radiation to warm the astronaut up. There was a light in the airlock, so we designed it with the plate that you see here is white. That's actually got bulbs behind it, so that can be turned on. Even in the museum, that's actually got switches in it, so you can turn that on. They never do. You can see in his hand, he is holding a shooting stick, an ordinary shooting stick. And that was if he got tired on the surface of the moon, he could simply place that on the surface and then sit on the shooting stick to get some rest. Now, you can just see in the left-hand picture the geological hammer sticking out behind his arm. He would never have been able to reach that. Another thing that was borne out by actually making the suit in 3 dimensions. It's very, very difficult to wear. I've worn it once, as you see here, and this is about the only time I'm smiling when it was finally finished. It was an absolute swine to put on and take off, and I don't think sitting in 1/6 gravity in the spacecraft would have helped this situation. There's the woolen communications carrier, the comm cap there, and you can see just around my neck, you can see a throat mic as well. So we're getting to the end of the lecture, ladies and gents. The high road to the moon. Smith and Ross envisaged this suit being worn on the surface of the moon. Would it have worked? Well, this is the question we get asked again and again and again. And the answer has to be in what we call the Mark I. This one here, I have to say no. Absolutely not. There are so many aspects of the Apollo suit look superficially similar, but have been completely ignored here. Micrometeoroid penetration, thermal control. It's just not thought through, really. But Smith and Ross had started that process of thinking. To finish, somebody said to me on one occasion, what do you think their design would have looked like over the evolution of their suit? So I just sat and penned what I considered the suit might have looked like. Here we've got what I call the Mark VIII. I think it would have gone through design development upon design development, more money thrown at it. It would have needed state backing, of course, and we were simply out of money at the end of the Second World War. There's the helmet. There's those large rubber arms, a bit like the tomato worm suit from 1943. We've got boots, a lot more like Apollo boots. We've got a built-in hard upper torso, much like they're talking about now for Artemis and the return to the moon, the Project Artemis. We've got convolutes at the hips to give a bit more movement there. We've still got elements of the suit being black to absorb radiation. We've still got elements of the suit being silver to reflect radiation. But I think that ultimately we're in the world of fantasy here. What this project gave me was an insight into the mind of Smith and Ross. I think they would have been straight down to Seba Gorman in Chessington to look at diving technology, which after all, there's 100 years of understanding of how to make a pressurized, rubberized garment. What it does say is that we were really thinking about leaving the bonds of Earth and going to the moon at a time when Britain had nothing. It's been a real pleasure doing this lecture for you, and it's a real pleasure making this suit for the museum. If ever you're in Leicester, do go up and have a look at my handiwork, and it'd be an honour for you to come back to us and let me know what you think. But in the meantime, ladies and gentlemen, thank you very much indeed for listening. My name is Stephen Wisdom. I'm awhistory.co.uk, and it's been a pleasure talking to you. Thank you very much indeed.